Hello, my name is Jiri Svoboda and I am from the Astronomical Institute of the Czech Academy of Sciences. And I would like to talk about spectral states of active galactic nuclei, AGN. They have supermassive black holes of millions to billions of solar masses. To understand the evolution of these relatively large accreting black holes, it might be useful to look at their much smaller stellar mass counterparts, the black holes in X-ray binaries. They evolve more rapidly, exhibiting different accretion states. In the soft state, the accretion disk goes down to the innermost stable circular orbit around black hole, and the emission is dominated by the thermal emission of the accretion disk. In the hard state, the accretion disk may be truncated at a far radius, and then continuing as an advection-dominated accretion flow. Typically, a strong X-ray corona is built in these systems, producing very hard X-ray photons, and therefore also the X-ray spectrum is largely different for the source in the soft and hard state. The X-ray hardness is then useful to use in the hardness intensity diagram to trace an X-ray binary outburst, going from low hard state to hard state and then soft state when the thermal emission of the disk is the dominant in the spectrum. The transition from the hard to soft usually happens at higher luminosity than the transition from soft to hard. And the most interesting feature is the production of a relativistic, highly collimated outflow, the jet, in the hard state, while the jet is quenched in the soft state. Also for AGN, we know galaxies that are radio loud and having these relativistic jets and radio quiet that don't have production of the jet. So this is the main motivation for building the hardness luminosity diagram also for AGN, to see where the radio loud sources are in the hardness luminosity diagram positioned. To do that, we need to use multi-wavelength observation, because the thermal disk emission is for AGN in UV instead of the X-ray, because the disks are larger and colder. So we built this hardness luminosity diagram for 1500 unobscured AGN observed simultaneously in UV and X-ray by XMM Newton satellite. The color here denotes the radio loudness as obtained from the VLA first survey, and you can see a clear concentration of the radio loud sources towards the right upper part of the diagram, also shown by the side plot histograms showing the relative radio loudness per hardness or luminosity. In the low luminosity end, the AGN behave slightly different in this diagram than X-ray binaries. In X-ray binaries, they go straight down, but in this case, the AGNs are always surrounded by the host galaxy. And in this plot, we show non-AGN distribution of the hardness and luminosity. So basically, the distribution of the color and luminosity for the host galaxy that are dominated by starbursts in optical and UV energy band. That's why any low luminosity AGN that is affected by the host galaxy has the trend to a bit shift to the left, to the softer part of the diagram. And not only radio loudness, but we are also interested in radio morphology that can trace the accretion evolution. Emily Moravec analyzed the different population of radio galaxies in the hardness luminosity diagram. According to Fanarov-Riley classification, the sources classified as FR1 have more radio emission coming from the center, so they have more compact jets. While the FR2 sources, the blue points in this diagram, are dominated by the radio emission from the extended radio lobes. This might be related to the density of the intergalactic matter environment, but also depending on the accretion state, whether the jet was already evolved, had the time to evolve into large structures. So FR2s might have more later jets evolved in the system than FR1s. And indeed, in the hardness luminosity diagram, the populations have slightly different position. The FR1s maybe are preceders of FR2s. So my conclusions are that there are qualitative similarities that we see between the AGN and X-ray binary spectral states, and that the difference of the position according to radio morphology might be an indicator of that the morphology can be affected not only by the environment, but also by the spectral state evolution that might be similar to X-ray binaries. So thank you very much for your attention.